This video will show you how to do multivariable optimization. So first off, f of x of AB is a local maximum if f of AB is greater than or equal to f of xy for all xy in the region. And f of AB is a local minimum if f of AB is less than or equal to f of xy for all xy in the region. A saddle point is a point where the graph increases along one line parallel to an axis and decreases along a perpendicular line parallel to the other axis. So here's a drawing of the three situations. This is a local maximum. Think of the top of an umbrella as a local maximum. Here is a local minimum, drawing of a local minimum. Think of the bottom of a bowl as a local minimum. Drawing of a saddle looks like this. Think of it as the shape of a saddle for a horse or the shape of a Pringles potato chip. Local extrema for a function. Let f of AB be a local extrema for f. If f sub x and f sub y both exist at AB, then the partial derivative of f respect to x of AB equals 0, and the partial derivative of f respect to a to y of AB is equal to 0. AB is called the critical point. The second derivative test for the local extrema. Test the local extrema. Z is equal to a function of xy, with the partial derivative of f with respect to x at AB equal to 0, and the partial derivative of f with respect to y at AB equals 0, where AB is the critical point. Let D of AB equal the second partial derivative of f with respect to x and x at AB times the second partial derivative of f with respect to y and y at AB is equal to the second partial derivative of f with respect to x and y at AB times the second partial derivative of f with respect to y, x at AB. Case 1. If D is greater than 0 and the second partial derivative with respect to x of AB is less than 0, then f of AB is a local maximum. Case 2, if D is greater than 0 and f of the second derivative of f with respect to x of AB is greater than 0, then f of AB is a local minimum. Case 3, if D is less than 0, then f of AB is a saddle point. And case 4 is if D is equal to 0, then no conclusion can be made. So it could be a maximum, it could be a minimum, it could be a saddle point, it could be none of these. One cannot tell from this test. So let's take an example. Let's find the local extrema for f of xy of 3 minus x squared minus y squared plus 6y. First, find the partial derivative with respect to x and y. So the partial derivative with respect to x is going to equal minus 2x. The partial derivative with respect to y is going to equal minus 2y plus 6. Now find the critical points by setting the first partial derivatives equal to 0. So f sub x is equal to minus 2x equals 0, x equals 0, and f sub y is equal to minus 2y plus 6 equals 0, so y equals 3. Now find the second partial derivatives with respect to x and y. So f with respect to x and x is going to be minus 2. F with respect to y and y is going to equal to minus 2. And f with respect to x then y is going to equal the same as f with respect to y then x is going to equal 0. The critical point is 0, 3. Now find the second partial derivatives evaluated at the critical point. So for the critical point 0, 3, f of x at 0, 3 is going to equal negative 2. F sub xy at 0, 3 is going to equal f sub yx at 0, 3 is equal to 0. And f sub yy at 0, 3 is equal to negative 2. So D is equal to f of x evaluated at 0, 3 times f sub yy at 0, 3 minus f sub xy at 0, 3 times f sub yx at 0, 3. So that will be negative 2 times negative 2 minus 0 times 0. That's equal to 4. 4 is greater than 0. So f of 0, 3 is either a local minimum or a local maximum. The sign of f of x at 0, 3 is less than 0. So then f of 0, 3 is equal to 12 is a local maximum. Example 2. Find the local extrema for f of xy is equal to x squared minus y squared plus 2x plus 6y minus 4. First, find the first partial derivatives with respect to x and y. So the f sub x is going to equal 2x plus 2, and f sub y is going to equal to minus 2y plus 6. Now find the second partial derivatives with respect to x and y. So f sub x is going to equal 2. F sub xy is going to equal f sub yx. It's going to equal 0. And f sub yy is going to equal negative 2. Now find the critical points by setting the first partial derivative is equal to 0. So f sub x, which was equal to negative 2x plus 2, is equal to 0. So x is equal to negative 1. And f sub y is equal to minus 2y plus 6 is equal to 0. So y is equal to 3. And the critical point is negative 1, 3. Now find the second partial derivatives at the critical points. So at negative 1, 3 for the critical point, f sub x at negative 1, 3 will equal 2. F sub x y at negative 1, 3 is going to equal f sub y x at negative 1, 3 is going to equal 0. And f sub y at negative 1, 3 is going to equal negative 2. So D is going to equal f sub x of negative 1, 3 times f sub y at negative 1, 3 minus f sub xy at negative 1, 3 times f sub yx at negative 1, 3 is going to equal 2 times negative 2 minus 0 times 0 is equal to negative 4, which is less than 0. So that says that f of negative 1, 3, which is equal to 4, is a saddle point. Example 3, find the local extrema of f of xy is equal to 2x squared minus xy plus y squared minus x minus 5y plus 8. First, find the first partial derivative with respect to x and y. So the partial derivative of f with respect to x is going to be 4x minus y minus 1. And the partial derivative of f with respect to y is going to be minus x plus 2y minus 5. Now find the second partial derivatives with respect to x and y. So f sub x is going to be 4. F sub xy is going to equal f sub yx. That's the partial derivative of f with respect to x, then y. That will get you negative 1. And f sub y is going to be 2. Now find the critical points by setting the first partial derivatives equal to 0. So f of x, which is equal to 4x minus y minus 1, so f sub x, is equal to 0. And f sub y, which is equal to minus x plus 2y minus 5, is equal to 0. You have a system to solve, so we need to solve this system. The system is 4x minus y equals 1, minus x plus 2y equals 5. If you multiply the first equation by 2 and the second equation by 1, so 2 times 4x minus y is equal to 2 times 1, and 1 times negative x plus 2y equals 5 is going to give you 8x minus 2y is equal to 2, and minus x plus 2y is equal to 5. Adding the two equations together, you get 8x minus x is 7x is equal to 7. So x is equal to 1. So minus 1 plus 2y equal to 5 says that y is equal to 3. So the critical point is 1, 3. The critical point of 1, 3 gives me the second partial derivative with respect to x and x at 1, 3 is going to equal 4. The second partial derivative with respect to x, then y at 1, 3 is going to equal the second partial derivative of y with respect to x at 1, 3. And that's going to equal negative 1. And the second partial derivative of f with respect to y and y at 1, 3 is equal to 2. That says D is equal to f sub xx at 1, 3 times f sub y at 1, 3 minus f sub xy at 1, 3 times f sub yx at 1, 3 is going to equal 4 times 2 minus negative 1 times negative 1, and that's going to equal 7, which is greater than 0. F sub xx is greater than 0. So f of 1, 3, which happens to equal 0, is a local min. Note, and all of these examples show only one critical point. There could be multiple critical points. And you need to test each one using this method to classify the extreme values of the functions at each critical point.